So one more very important component is data lake. We have talked about data warehouse, we have talked about OLAP databases, OLTP databases, data mart and data mesh. So it is time to bring in another important concept in today's big data world or today's data engineering world, that is called data lake. Data lake is a little different than OLAP databases or OLTP databases or data mesh and data marts. So data lake is a centralized repository that stores structured, semi-structured and unstructured data at any scale. So these are the highlighted points. If you see here, it stores structured, semi-structured and unstructured data at any scale. For OLTP systems, we had seen various technologies like relational and NoSQL databases. So you might already know that relational databases have a structure. So when you create tables in relational databases, you have to mention the columns and their corresponding data types. For NoSQL databases, essentially the databases are schemaless, or the schema is semi-structured, either in JSON or XML or key value stored. But unstructured data are not meant to be stored in either relational or non-relational databases. For that, data lake makes more sense. As you can store unstructured data, you can also store structured and semi-structured data at any scale. When I say at any scale, it can be hundreds of petabytes or exabytes also. The highest that I have seen so far in my work experience is approximately 230 petabytes in S3. So, what are structured data in data lake? Like CSV files, XLS files, Parquet file format, Avro and ORC. These are structured data on data lake. So as you can see, I'm not talking in terms of database. I'm talking in terms of files. CSV file, XLS file, Parquet format file, Avro format file, ORC format file. These are structured data. In semi-structured data, we can store JSON files or XML files. XML files are not used that much. So when you talk about semi-structured, it is mostly JSON files. Again, I'm saying JSON files, not semi-structured records. Then for unstructured data, we have JPEG files, PNG files for pictures, documents, docx for documents, MP4 for video, PDF for again documents, binary data, let's say music, audio files, video files, etc. These are unstructured data. Again, these are also files. I'm not talking about records. So, data lake is essentially used to store raw data and processed data also. We can create something called Lakehouse also on top of data lake. But data lake can be used to store both raw data and processed data. And we can read directly from data lake using various tools like native tools. For example, AWS S3 has something called S3 Select, which can be used to read data directly from S3, which you have already seen in the S3 video. We can use Presto also, Athena also, for that matter, Redshift, BigQuery, etc. to read data directly from data lake. So these are the technologies for data lake. On AWS side, we have Amazon Simple Storage Service or Amazon S3. From Google Cloud, we have Google Cloud Storage or GCS, and from Microsoft Azure, we have Azure Data Lake. So these are the data lake storage services that are provided by various cloud providers. Obviously, we have seen videos of Amazon S3. Just to reiterate how data lake store data, as we are using Amazon S3 as data lake, how do they store data? We have already seen that in the S3 video, but I'm just reiterating how the data is stored. Now, the entire file is stored as a whole, meaning that we do not store record by record. We upload files in an S3 bucket. So whenever we uploaded files in S3, we created something called a bucket, and in that bucket we uploaded multiple files like CSV files, Excel files, PDF files, JPEG images, Parquet files, etc. So we upload the entire file as a whole. We cannot do any record processing. We cannot read an individual record from that particular file. These are some objects in an S3 bucket, like all four are CSV files, and we call them as objects. Why objects? Because these are binary objects that we stored in a data lake. Now we store the entire file as a whole. If we have to read individual records from these files, we'll have to use tools like S3 Select or Redshift or Athena or like Presto, etc. We cannot read them from the object stored directly. We need a storage engine or a query engine for that. So as you can see, we have certain drawback in data lake. We cannot update the records, by the way. So we can read the records using S3 Select, using Presto, using Athena, using Redshift Spectrum, but we cannot write records. We can write records in OLTP databases. We can write records in DWH or OLAP databases. We can modify individual records in these database paradigms, but we cannot do the same in data lake. We cannot modify individual records in data lake, because what we do is that we store the file as a whole. So if you have to, let's say, modify a single record, we'll have to download the file, just modify that record in that file and upload the file again. So that's the disadvantage of data lake. It does not give you the capability of modifying individual records. Data lake is very important for today's big data processing, for today's data warehouse processing. So to overcome that, data lakehouse was implemented. What is data lakehouse? Data lakehouse is the combination of data lake and data warehouse. So why data warehouse is here? Because we can modify individual records as we do that in data warehouse. So it's a mixture of data lake and data warehouse. That's why you have data lakehouse. So lake from data lake and house from data warehouse is data lakehouse. Now using this, we combine the capabilities of data lake and data warehouse. So using data lake, we can store structured, semi-structured and unstructured data at any scale. And using data warehouse, we can do historical analysis, we can do record level modification, we can run SQL engine on top of it. So we combine these two together to create data lakehouse. So using data lakehouse, we can actually modify individual records in a data lake. So that is the whole and sole purpose of lakehouse. So now using data lakehouse, you can actually combine data warehouse and data lake. In some cases, you can replace a data warehouse using a data lakehouse also. Now, of course, it does not come out of the box. This is a picture that I have taken from databricks.com. So if you see on the left hand side, we have structured data. So this is data warehouse. So what is data warehouse? So data warehouse is essentially gets record from structured data, which are operational data stored. We run some ETL and move it to data warehouses. And then we use business intelligence and reporting tools to run reports on top of it. That's what data warehouse is. Now in data lake, what we do is that we upload structured, semi-structured and unstructured data in a data lake. We run ETL, move it to data warehouse from data lake, which we'll see in our Redshift hands-on also. And then we run BI and reporting tools on top of data warehouse. And also we expose the data warehouse to our data science teams also, so that they can run data analysis queries. And if we have, let's say, machine learning tools get access directly to the data lake. Now data lakehouse combines these two together. So we have a metadata and governance layer on top of data lake, and we can combine all of these things together. We do not need an additional ETL. So we can actually remove the ETL process. So how do you do that? The technology enablers are open table format. We have various open table format like Iceberg, Hoodie. Hoodie is basically full form is Hadoop update delete insert, and then Delta Lake. So Delta Lake was created by Databricks. These are the metadata and governance layer that you are seeing here. So this layer is essentially handled by these technologies, Iceberg, Hoodie, and Delta Lake. So using this, we can create data lakehouse. So I have talked enough about various technologies. Now let's see what is the role of a data engineer. So again, this is the one of the first diagrams that I have shown you in this particular section. So we have source systems, we have various sources, and from there we get data to databases, message brokers, data lakes, do processing, move it to data warehouse or message broker or data lake or data lake house, and then the downstream applications like machine learning or visualization applications use this data from the data warehouse, data lake house, or data lake. As a data engineer, you'll have to know the source systems, meaning the source database systems or OLTP systems like the OLTP databases, message brokers like Kafka, Kinesis, data lake like Amazon S3. You need to know the processing layer also, like Apache Spark or Kafka Streams or Flink, etc. And you have to know the data warehouse, data lakehouse technologies also. So in this particular course, I'll be talking about data warehouse. I'll touch base a little bit on data lakehouse, and I have also already talked about data lake in S3. And I have other courses wherein I talk about the processing layer and real-time processing and batch processing using Spark, Kinesis, Kafka, Glue, Kafka Streams, and Apache Flink. If you are interested, please enroll for those courses as well. And please leave comments if you want me to create a course on databases as well. If I get enough input, I will go ahead and create a course on OLTP databases as well. Now we are at the last leg of our first section. Before wrapping it up, I want to talk about various use cases of a data warehouse. Again, I just want to reiterate, I have already talked about this earlier. The first use case is reporting. So using data warehouse systems like Redshift, we can create tactical and strategic reporting so that we can take either tactical or strategic business decisions based on those reports. We can also create decision support system. Again, the input to decision support system would be essentially the strategic or tactical reports. So using those reports, you can take various decisions and you can create a decision support system or DSS for a business organization. Data warehouse technologies like Redshift can also help in predictive analytics and forecasting. Based on the historical information of your business, you can predict the future of your business also. We can do some forecasting, and it happens a lot across various organizations. So data warehouse plays a very important role in this predictive analytics and forecasting business outcomes. As I already told you, we can understand the business health using historical analysis, because in data warehouse systems in Redshift we store huge amount of data, huge amount of historical data. So using that historical data, we do historical analysis to understand how our business is performing, and using that we can get crucial business indicators over time with this analytics and reporting. We can see a graph, we can plot a graph how the business performed in various seasons or in various scenarios, so that we can make the business more prepared in future different scenarios. Now, one of the most important things of important characteristic of Redshift or data warehouse technologies is data integration. What we do here is that we extract data from various systems, various OLTP systems or message brokers or any other places, do processing, do some transformation, and store them in one place. So by storing them in one place and doing transformation on top of it, we enhance the quality of data by enriching it, by doing aggregation, by doing transformation, etc. And of course, these can be helpful in compliance, reports, regulations, various regulations, and auditing purposes. You can also use data warehouse systems for personalized customer service. Just to give an example, if you have bought online products using, let's say, Amazon.com, you might have seen that you get product recommendations. So your product recommendations come as per your buying pattern. So that is a personalized customer service. Your product recommendation would be different than that of mine. The recommendation is coming from predictive analytics using the data that is stored in data warehousing systems like Redshift. We can also do fraud analysis using data warehousing systems. So let's say we store our transactional data for over a period of time. We can use Redshift as a ledger system, and we store all the transactions that I have done using my debit or credit card. And let's say whenever I do a new transaction, it goes and checks whether the transaction matches with the pattern that I have been doing so far. If it does not, then I'll get a notification in my phone that okay, your transaction pattern does not match. So let's say my transaction has been from 10,000 to 50,000. Suddenly I do 200,000 a transaction worth 200,000. So if that is the case, I'll get a notification on my phone that okay, whether it is me actually who is doing the transaction. So that can be enabled by data warehouse systems. Of course, there are machine learning models which have to be created on top of it, but the base of that machine learning model can be data warehousing systems like Redshift. Finally, we can use data warehouse systems or OLAP databases as an input for data pre-processing needed in machine learning. So as I said, the same case is true for fraud analysis also. So the data is there in your OLAP databases or DWH systems, and from there it can be sent to a machine learning model to understand your transaction pattern. Now this is a diagram that I wanted to show you. This is basically a unified data platform. So if you see here on the source side, I'm not sure whether you can see it or not, but I'll just voice it over. So these are the source systems like OLTP databases, ERP systems, operational applications, logs, third-party APIs, etc. From there, we moved the data to various storage systems like data lake, data warehouse, and maybe real-time analytics also. Then we do some transformation, and finally we move it to analytics output. Now, where does AWS fit into all this? I've talked about the entire data lifecycle. What services or technologies AWS provide us in this entire data lifecycle? So again, this is a very busy slide, but I'll just walk you over. So these are the various data sources. On the data sources side, we have Amazon Aurora, which is a relational OLTP data store. We have Amazon DynamoDB, which is NoSQL OLTP data store. Amazon RDS, which is again another relational OLTP data store. IoT Core, from again we can get data from various IoT devices. Of course, there are a lot of other data sources also. I have not mentioned all of them. Then we ingest data using, let's say, AWS Data Sync or Storage Gateway. So if you are using the data pipeline, would be essentially using batch or streaming ingestion. So using batch ingestion, in batch ingestion rather, we can use AWS DMS or data management database migration service to move data from these data sources to other storage systems. We can use Amazon EMR or AWS Lambda or AWS Glue. In streaming systems, you can use Amazon Kinesis or Amazon MSK to get data from streaming sources and move it to the storage systems like either Amazon Redshift or Data Lake, which is Amazon S3. Redshift being the data warehouse. Of course, we do some processing. So we get the data from batch sources or streaming sources. We run processing on top of it, and then we store it in data warehouse or data lake systems. Now, in the processing layer, we can use Amazon Athena, Amazon EMR, AWS Glue, AWS Lambda, or AWS Managed Service for Apache Flink. So these are the processing layers. On the consumption layer, we can have Amazon QuickSight, Amazon Athena also, which is a SQL engine on top of data lake, or we can use Amazon SageMaker or Bedrock for machine learning. We have something called cataloging service, which are used for mainly data lake and can be used for data warehouse systems also. So AWS Glue data catalog and AWS Lake Formation are part of that cataloging system, and both the storage system and the processing system communicate with the catalog layer. And finally, we have security and governance, which is AWS IAM and AWS Lake Formation. Now, in this course, what I'm going to talk about, I have already shown you what S3 is with hands-on. Of course, it was not as deep as Redshift is going to be. Of course, I'll be talking about Redshift. I'll talk about Amazon QuickSight and Amazon Athena. I'll also tell you about AWS Glue and Lake Formation. Again, deep dive, not high level. So AWS Glue data catalog, not the processing. On the batch side, we'll talk about AWS DMS. So how do you get data using AWS DMS from data sources like Aurora or DynamoDB or RDS to Redshift. In the processing layer, I'll just scratch the surface of AWS Glue, nothing else. And using AWS Glue, how can you move data from, let's say, streaming sources to Redshift, or batch processing from Aurora to Redshift. If you want to know the other services like Amazon EMR, AWS Glue, Flink, etc., as I already mentioned, I have courses for those. Please enroll for those courses if you are interested. And as I said, if you send me enough comments or enough messages about data sources like OLTP databases, I'll prepare a course for that one as well. So that's all about this section.